Now we have to move on to the next presentation. Our next presenter is Dr. Yee Mun Lee, who is a research fellow at the Institute for Transport Studies from University of Leeds, so my colleague. She will talk about understanding pedestrians' trust in an approaching automated vehicle. So from the outside of a vehicle view. Welcome, Yee Mun.
Thank you. I hope you can see my screen now and can hear me.
Yeah, I can see and can hear.
That's great. So thank you very much for the introduction. I'm Yee Mun, and that's my first name. And today, instead of focusing anything on board, I'm focusing, towards the external road users, mainly talking about the pedestrians' AV interactions from the outside perspective, the studies. The kind of studies we've done within Interact as well as in Leeds, and providing a summary in terms of what do we know now, and what the next step should be in terms of future research. So let's start with the main objective of Interact, which I think this is a very nice, easy way to explain that this study topic is very important, is that in the future, the automated vehicles not only have to interact with the onboard users, but it's also important for them to interact with other road users. So for example, the other car drivers, which is on the road, other pedestrians, other cyclists, and it is going to be a mixed traffic environment. And not only that the onboard users have to trust automated vehicles, but also, those other road users, which is around the vehicle, that have to be interacting with the automated vehicle. And we started by trying to define what interaction actually is. And as you can see, there's many types of interactions that could happen on road. And there's different pathways that at least two approaching vehicles or road users will be able to interact with each other. And we define interaction as the situations where the behavior of at least two road users can be interpreted as being influenced by the possibility that they are both intending to occupy the same region of space at the same time in the near future. And that's what interaction is about. And when it comes to interacting between two road users or more, there's a lot of behaviors that's emerging, which could be trying to achieve something, or trying to communicate, signal something, or trying to request something. So we also have this Venn diagram of different taxonomy about categorizing different behaviors and what that behavior is trying to communicate or trying to do. Before we try to think about how automated vehicles should behave, or whether external information is important and things like that, we try and observe the current interactions between road users. So when I meant current interactions, what I actually mean is that the current conventional vehicles. So what drivers are actually doing now on the road with other drivers in terms of communicating, or with other pedestrians in terms of communicating. And according to many studies, we actually found that pedestrians vehicle interactions suggest that pedestrians typically use behavior of the vehicle to helping to make crossing decisions. So we can see that the behavior, how the vehicle actually maneuver, the kinematics information is an important factor. Within Interact, we did try and observe in 6 different locations, 3 different countries, including we have it in Leeds, Germany, and Greece, Athens specifically, over thousands of cases of interactions between the pedestrians and drivers. And what we've seen, at least in this 50 kilometers per hour road in all these junctions, road users rarely use explicit communication. So we haven't observed much of honking behavior, flashing headlights, giving you a hand wave, and information like this. However, when it comes to a similar observations in the parking scenario, we did find a bit more, non-verbal communications between them, which potentially is because due to the low speed of environment in the parking scenarios, right? So we found an association between looking behavior and, depends on it affects who took priority in that studies. So there is some importance in terms of non-verbal communication, and explicit communications do exist in different areas that we're talking about. Not only, of course, we're not observing in this 50 kilometers per hour road doesn't mean that it does not exist, right? So, and we're trying to also investigate a bit more in terms of kinematics information, how it actually affects crossing behavior. On roads observations, you are able to observe whether things happens or not. You're able to observe, a lot of associations, but not specifically the cause and effects that we're talking about here. So we did a lot of simulator studies, pedestrian simulator study, trying to investigate how speeds, for example, how time gaps affects crossing behavior. And we often found this bimodal crossing pattern when the vehicle is yielding. So bimodal crossing pattern is that the pedestrians either crossed when the vehicle is very, very far away before vehicle is even decelerating, or they wait until vehicles comes to a nearly stop. They seldom cross in between when the vehicle is decelerating. So that's why it caused this bimodal two peaks of crossing pattern that we often observed. In addition, we also try and understand, whether the presence of an obvious drivers on board versus an attentive drivers versus an distracted drivers, how that driver's element actually affects pedestrians' crossing behavior. So we did not, all the speed and decelerations are all controlled, just merely trying to compare how the presence and attentiveness of drivers affects crossing behavior. And what we found is that crossing initiation time was longer in the distracted driver's condition, although the effect was very small, but participants had a higher perceived risk when interacting with a distracted or no driver's condition and a lower perceived behavioral control as compared to an attentive one. So we've seen in one of the previous talk, I believe it's Hai Lung's talk, that there's this videos where there's this approaching car which has no drivers on board, no additional information, and pedestrians like, oh, okay, what is the vehicle doing? Is stop. Okay, let's just cross very fast. That kind of behavior is that what we're talking about here, right? So when there's no drivers or when the drivers is distracted, people feel like, they have a higher risk in terms of crossing and they have a lower perceived behavioral control. It raises questions of, whether the additional external informations here is potentially might be helpful in trying to, convey some message to the pedestrians that, okay, I look distracted, but, it is automated vehicle, so I'm not driving, but the system is driving itself. So that kind of information might be helpful. And therefore, trying to replace all this human element or driver's element, there is various concepts by different OEMs coming up. There's projections, there's eyes on the cars, there's text-based information, there's some using, traffic lights, red and green system, giving you a smiley face, etc. and etc. And there is also lots of studies which actually found eHMIs beneficial in many ways. So for example, AVs, which has eHMIs, are deemed to be more informative. They're more preferable to those without an eHMI. And it also decreased the mean of decision-making time. So people make decisions a bit quicker when there's eHMI. And it improved comfort, trust, acceptance, receptivity, perceived safety, for the pedestrians, so people feel subjectively better when it comes to interacting with an with an AV with the eHMI. So percentage of the feel safe to cross increased, as well as more pedestrians willing to cross when eHMI was present. So there is various of benefits of eHMIs. However, a lot of these studies have not taken into account of the manipulations of vehicle kinematics that we knew it was very important. As there's a lot of kinematics information which deemed to be more important than the explicit communications that we have observed on road. And because of this reason, we conducted this particular study, which has two aims. The first aim is that we try to understand how the combinations of eHMI and kinematics information play a role in pedestrians' crossing behavior. Because in previous study, we found that pedestrians already crossed when the vehicle is very far away before deceleration even happened, or they wait until very, very last minute when the vehicle comes to a near stop. So we want to see at which different speeds and time gaps eHMI will be effective in affecting people's crossing behavior. So that's the first aim. The second aim is that we use the flashing headlights as a benchmark to investigate how a novel eHMI affects crossing behavior. Why a novel eHMI is important? Because we do not want a text-based information eHMI. We do not want to instruct people what to do. We do not want to use the green and red lights system, because that's going to, people might misunderstand what the eHMI is about to tell them, because, we don't want to be having an instruction green means you can go, because that's going to be potentially very dangerous. So what we're going to do is to use a novel eHMI, and in this case, it was a slow pulsing light band, which is trying to communicate I'm yielding, which was rated as associated with the message I'm yielding in one of our previous studies. And how the novel eHMI was learned as compared to the flashing headlights. Flashing headlights is one of those communications methods that drivers use, often trying to tell you that I'm here, or I've seen you, or I'm going to slow down for you, or even don't cross in front of me, depending on cultures. But people do use flashing headlights, even though sometimes it might be illegal to convey certain message. And we also attempted to understand how eHMI visibility as well as comprehension actually affects all these crossing behaviors. So findings, what you're seeing here is that this are the percentages of crossing, and these are the distance of the second vehicle when pedestrian initiated crossing. So where the vehicle is located at when pedestrians start crossing, that's what it is about. And as you can see again, there's this bimodal crossing pattern. So that's the line of which the vehicle starts to decelerate, 38.5 meters. So what we're seeing here is that a lot of people have crossed before the vehicle even decelerates. So that's what I've mentioned previously, or they wait until very last minutes that, within 5 meters before the vehicle come to a full stop at 2.5. So again, this bimodal patterns is observed. However, you might be able to see this different pattern here, which the other threes are very similar, it's almost overlapping. And over here in this black line, what you're seeing here is when the flashing headlights was on. So what it is showing here is that more people willing to cross when the vehicle is decelerating rather than waiting until the vehicle comes to a near stop. So we have basically break the pattern of the bimodal crossing pattern that we often observed. And this star here indicates when the flashing headlights was perceivable. So the flashing headlights was perceivable at this particular distance. And then soon after, you see a peak in terms of the crossing. However, this is when the slow pulsing light band was perceivable, even though it is significantly nearer as compared to the flashing headlights, but you do not see this peak in terms of crossing. So it did not trigger people's crossing, because people are more familiar with the flashing headlights, probably understand the flashing headlights more than the slow pulsing light band, which is a novel eHMI. So what we're telling here is that, not only the visibility is important, but the comprehension and understanding of the eHMI is also important. So we also try and understand the crossing initiation time, which is the time that took pedestrians to initiate crossing as soon as the gap is opened. And we use this metric, which is the CAIT change. So if the CAIT eHMI is present minus absent, then a negative values would indicate there's a CAIT reduction, which means then people cross quicker when there is a negative value that we are seeing here, as vice versa as well. So the second aim is learning effects. So the CIT change differ across blocks for both eHMI. So what you're seeing here, again, this huge black bars representing the flashing headlights. We have block 1, block 2, and block 3. You can almost immediately see that there is this huge effects for flashing headlights, but this very tiny effects for slow pulsing light band, and then it decreases slightly across block 2 and block 3, but still is not as big as what we can see here in flashing headlights. This is typically telling us that, if people are very familiar with that eHMI, they know what eHMI is trying to communicate, then there is an immediately effect as compared to the novel eHMI that we're seeing here. especially at lower speeds and time gaps. I have to mention that because that's also manipulated, but I did not show any more, findings here because of the time. So what happens if people cross quicker, cross when the vehicle is still decelerating? That's what we are trying to investigate in this other study, which is, what we've done is to manipulate the eHMI onset to be 1 second before it starts decelerating or 1 second after it starts decelerating. So we have this after a series of functioning eHMI. So trial 1, eHMI, people cross, trial 2, eHMI, people cross, and then we provide a failure trial, 2 failure trials to actually investigate how people behave. Failure trials are eHMIs is on, but vehicle is actually not decelerating. So in general, pedestrians entered the road earlier and report higher trust, higher comprehension, lower risk when the eHMI was on compared when it was off. So this is just a replication findings that we've seen across many studies. And the results actually show that when eHMI was on, participants in the negative 1 second eHMI onset group entered the road earlier. So if the onset is 1 second before it actually decelerated, participants enter the road quicker, right? And there is a higher trust as compared to the +1 if the eHMI actually switch on 1 second later. So if 1 second earlier people have started crossing, it almost means that people are not really focusing much in terms of the kinematics information, but already see lights and then they start crossing. What's going to happen in terms of safety impact? So there's this after a series of functioning eHMI, and this is basically showing when the vehicle is actually not decelerating. So this is across all these trials, number 1 to 25, however many trials we have. So these are the 2 failure trials that we're seeing here, and that is indicating. And the gray area is the road length. So this is indicating the pedestrian. These pedestrians are already on the road when the vehicle has already arrived at their crossing path. So these are when the collisions happens. So the first failure trials had a strong effect in the sense that as much as about 35% of trials participants entered the road. So these are the people that see lights and then start crossing when the vehicle is actually not decelerating. And, there's slightly less in the failure trial 2, which people have, learned, but not so much in this particular +1 group. Right. So what in terms of risk, trust, comprehension, and entering the road? As you remember, we have 2 failure trials. So that's, that's peak differences is when failure trials actually happen. So what I like to say here is that the results for perceived trust are consistent with Kai's studies, as well as this previous studies, found that when participants experience a failure of the automated system, then their trust declines strongly. So that is what happens, that if you provide a false information, then people are likely to have this collisions that's going to happen, or the trust reduce significantly. So what do we know now? Vehicles' behaviors are important. So more future studies should focus on how AV should behave. There's this eHMIs decreased CIT and improved pedestrian subjective evaluations. Many studies have found that, especially if comprehension, familiarity, and visibility of eHMIs are ensured. eHMIs failures and miscommunication can be severe, so more studies should focus on negative effects of eHMI and understand a bit more in terms of them. Future studies should look into more realistic, complex scenarios instead of one-to-one interaction, as we have seen in Hailong's this particular videos where pedestrians cross the first lane and second lane they get hit, because all this different 2 lanes of multiple interactions are important, including the long-term effects, like the analogy that Philip given, that after experiencing the dogs, then you get to know more about them. All these long-term effects, we haven't even studied them. How would that actually affect pedestrians' crossing behavior? Inclusiveness important. All the studies have been looking at reaction, so we provide a stimuli and see how pedestrians react, but not towards the other way around. So how would pedestrians crossing affect AV's interactions? So that is also important to be investigated in distributed simulator. So I know I've over time, so thank you very much. That's the end of the talk.
Thank you, Yee Mun. Thanks for the brilliant presentation. So do I have any questions from our audience? I saw Jingyi raise her hands. Go ahead, Jingyi.
Yeah, thanks, Yee Mun, for a nice talk. I actually just want to ask one question based on this across different situations and scenarios you mentioned. And I think it's really interesting, like you found in the parking scenario specifically, because the low speed scenario is a less time critical situation. It's gonna influence the pedestrians crossing behavior. But in reality, like there are tons of cases, right? And simply we, like researchers, we don't have time to investigate all kinds of scenarios. And I think you've also highlighted some maybe one of the most important factors, such as like the time or the speed, but just wonder if there were additional more important factors, or these two would be the one you like suggest future research to focus on first.
Yeah, so when I talk about, vehicle kinematics, there's more than time and time gaps that you should be looking at for example, distances, or even how the vehicle should decelerate. So deceleration pattern is also important, right? So a lot of all the studies for the, just to make it easier in terms of understanding deceleration, lots of them are constant decelerations rather than, there's this particular studies conducted by Andre within Interact as well, where he has this aggressive deceleration or passive deceleration. All this deceleration pattern is going to affect how pedestrians actually perceive what the vehicle is doing, or including deviations from or towards the pedestrians is also going to be, a kind of kinematics information. So not only speed and time gaps, a lot of all this kinematics informations, how it actually affects pedestrians crossing is important to be investigated, and that there are definitely not enough studies in them. So they are all very important. Yeah, there are lots of scenarios, and we of course do not have the time to investigate all, but that's one good thing is about collaborations and how research should be built, and not repeating too much of what others have been doing, but it kind of necessary up to this point, where it's always one vehicle, one lane coming from one direction. All of the studies are like that, but it's also, it was in a very beginning stage. We're very early, 2-3 years into trying to understand the eHMIs, or, how vehicles kinematics affect. So I do deem that they are necessary, but, it's probably time to expand a bit more so that, we really truly understand how people actually react to this, including all these attentions that pedestrians are actually having to focus on multiple directions, 2 different lanes, for example. Yeah, they are all actually very important. Definitely lack of study, so they are all important.
Thanks.
Thanks, Yee Mun. Oh, we have more questions. Yeah, just go ahead.
Me?
Okay.
Okay.
Yeah, sure.
Okay, thank you. I have a question about the eHMI design. As I know, a lot of study in Europe always use the light bar as the eHMI, right? And some study in China, in Japan, in Korea, use for example, the text. So I want to know the reason why in the Europe, the light bar is very important.
Okay. Yeah, so, okay, let's put it the other way. We don't think, it's not necessarily that we think light bar is important. It's that text is not practical in many sense, because first of all, because of comprehension, language issue. So not all can read that particular language, or in fact, not all can read. That's the second issue, right? The third issue is the visual conspicuity of the words. So how big the words has to be in order for people to be able to perceive, from a certain distance, or when the vehicle is moving at a certain speed. And another reason is that we do not want to necessarily provide a direct instructions, or walk, don't walk. A lot of the study using that as well, because we want to reduce the tendency of people merely following the instruction of what the automated vehicles is giving them. But then, because if anything goes wrong, then it is very dangerous situation. So because of text is not being practical. Therefore, we started to think about what are the other elements. There's a lot of projections or, you know, light bars, different types of light bars, different colors of light bars. But we're starting using light bars is because it is 300, or at least within Interact, is because it is a 360 degree, so people can see what the vehicle is doing or communicating from various angle. And we're using lights because, you know, flashing headlights is light, braking light is light. That's the reason why we're using light, and the reasons why we are having a 360 degree bars rather than one light. So yeah, we also do a bit of pre-test, and this is particular designs where pedestrians or participants actually chosen to be the one which is associated with the particular message. For example, in this case, yielding, not something that we just pick off the top of our head, but there's this pre-studies conducted before we test the crossing behavior.
Okay, thank you.
Okay, thanks again. Thanks, Yee Mun, for the presentation. I saw Hao also raised his hand, but sorry, I think we are a little bit over time, and so maybe it's easier to put the question in the chat, and Yee Mun, maybe you could answer that.
Yep.
Thanks again. Thanks very much.
Thank you.